Ask an AI this sentence. The trophy didn't fit in the suitcase because it was too big. Then ask it what it refers to. It says the trophy correctly every time. Swap one word, say because it was too small, and it flips its answer to the suitcase also correctly. It has never seen your exact sentence before. There is no rule written down anywhere that says it means this or that. So how does a model figure out, in a fraction of a second, which word a pronoun is actually pointing back to? The answer is a mechanism with a strangely simple name. It is called attention, and once you get how it works, a lot of AI's stranger behavior stops being mysterious. Here is the picture most people have in their head. They imagine the AI reading a sentence the way we do, left to right, one word at a time, slowly building up an understanding as it goes, like a person following along with their finger under each line. Under that picture, by the time it reaches the word it would have to be quietly remembering everything that came before, in order, and figuring out the connection as a kind of afterthought. That is not what happens. The model does not process your sentence in a line. It does not read word 1, then word 2, then word 3, carrying a growing summary forward. Every single word in the sentence gets looked at essentially at the same time, and every word gets to look at every other word directly, no matter how far apart they sit. Order still matters, sure, but not because the model reads in order. It matters because the model is separately told where each word sits in the sentence, the same way you'd hand someone a stack of shuffled index cards, along with a note saying which position each card came from. So what does every word looking at every other word actually mean, mechanically? For each word, the model builds 3 different vectors, 3 lists of numbers that represent that word in 3 different roles. One is called a query, and you can think of it as the question that word is asking. What do I need to know from the rest of the sentence to make sense of myself right now? Another is called a key, and you can think of it as the advertisement each word puts out about what it has to offer. The third is called a value, the actual content that gets shared if a match is found. Here's the trick. The model compares the query of one word against the keys of every other word in the sentence, using a simple math operation, and that comparison produces a score for every single pair. High score means strong relevance. Low score means mostly ignore this one. Those scores get squashed into percentages that add up to 100, and then the model builds a blended answer for that word by mixing in the values of every other word, weighted by those percentages. The word it ends up pulling in mostly the value of trophy, a little of suitcase, and a tiny sliver of everything else, because when it went looking, trophy scored highest as the answer to its question. That blended mix is what the model actually carries forward into its next calculation. It's not stored knowledge about grammar rules sitting in a lookup table somewhere. It's a live calculation, run fresh, for every sentence you type. This is exactly why the mechanism gets its name. It is quite literally the model deciding, word by word, what deserves its attention right now and what doesn't. And this one idea explains a bunch of behavior that otherwise looks like magic. It's why a model can resolve a pronoun 10 words back without remembering anything in the human sense. It's just running that same query and key comparison across the whole sentence and letting the highest score win. It's why a model can jump straight to a relevant detail buried in the middle of a long paragraph, instead of only caring about the word sitting right next to it. Because distance in the text barely matters, it's the content of the match that matters. And it's why the model handles a plot twist correctly. Flip too big to too small, and the word it recalculates its scores against every candidate from scratch, and suitcase suddenly wins instead of trophy, because the actual math of the sentence changed, not because some stored rule got flipped somewhere. Real models don't do this once either. They run many of these comparisons in parallel, called multiple attention heads, where one head might specialize in tracking who did what to whom, another in tracking pronouns, another in tracking punctuation and sentence structure, and their results all get combined afterward. That's also why this whole process gets stacked layer after layer, each one refining the blend a little further, so that a word's meaning by the final layer is really a mixture of the entire sentence's context, shaped specifically around what that particular word needs. There's a catch worth knowing about here, because it explains some AI weirdness you've probably run into yourself. Attention lets a model look anywhere in a huge wall of text, but it doesn't spread its focus evenly across all of it. Some words end up scoring high against almost everything, turning into these gravitational hubs the model keeps referring back to, while other words barely get noticed at all even though they're sitting right there on the page. That is part of why a critical instruction can get buried and quietly ignored in a long prompt, while a much less important detail near the start or the end gets treated like it's load-bearing. The mechanism isn't skimming randomly. It's running real comparisons every time, but those comparisons can land unevenly depending on what else is competing for the same limited attention. Think about what this looks like in practice. Say you paste in a long document and ask a question about one small detail buried in paragraph 12. The model isn't scanning top to bottom hoping to stumble onto it. It's comparing your question's query against the keys of every sentence in that document, all at once, and if the wording of your question overlaps enough with the wording around that detail, the match wins and the detail gets pulled forward. But if your question uses different words than the document does, that match can score lower than it should, and something less relevant but more textually similar can win instead. That's not the model being careless. That's the actual scoring mechanism producing a result you didn't expect, because relevance is judged by pattern match, not by understanding your intent the way a person would. So what does this mean for how you actually use one of these things? First, don't assume proximity is what matters to the model. Content match is what matters, so if you want two ideas connected, make sure your wording actually links them, don't just place them near each other and hope. Second, when you're writing a long prompt, put your most important instruction in a way that stands out clearly on its own, because a vague or buried version of it has to compete with everything else in the text for a high enough score to actually shape the answer. Third, if a model keeps latching onto the wrong reference or the wrong detail, try rephrasing the sentence so the connection is more explicit in the actual wording, since that changes what the query to key comparison finds. None of this is about tricking the model. It's about understanding that every response comes out of a live, word-by-word competition for relevance, and you get better results once you make the relevant thing easy to win. So the next time an AI nails a reference that should be nearly impossible to catch, or completely whiffs on something you thought was obvious, remember there's no memory and no hard-coded grammar rule making that call. There's a mechanism quietly asking, for every single word, which other words actually matter right now, scoring them, and blending in whichever ones win. That's attention. It's not the whole story of how these models work, but it's the piece that lets a wall of text turn into something that actually hangs together as meaning. And that is exactly what we do here, one clear idea at a time.